Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And today I'm up to a new section. I'm starting section 5.6 of volume 1. This is on cardinal numbers of sets. And in particular, today I'm gonna spend the next few lectures talking about cardinal numbers of various types of sets. Pretty fascinating subject, especially when we deal with cardinal numbers of infinite sets, known as infinite cardinal numbers. We'll see they have some really interesting and counterintuitive properties. But for today, I'm going to keep it very basic. I'm just going to talk about cardinal numbers of finite sets. So anyway, let's begin. So first I have to define a cardinal number. And when you talk about finite sets, cardinal numbers are really just very basic. It's just the number of elements in a set. So if you have a finite set, by definition, a finite set is a set with a finite number of elements. So if the number of elements is finite, it means you can count them all. And you'll get a finite number, and that number is known as a cardinal number. Sounds very basic, and it is. But I think I want to say one thing about that that's kind of interesting, I think. Um, if it, I mean, you might wonder, I guess I'm sort of jumping the gun a little bit here, but you might wonder if there's another way that you can determine if two sets have the same size without counting the number of elements in both sets. You might think if you have two sets with 20 elements, the easiest way to determine that they both have the same size is to count the number of set elements. And let's say the first set is A and the second set is B, count all 20 elements in set A, and then count all 20 elements at B. That's one way to do it. But actually, there's another way to do it that doesn't even involve counting. You can pair them off. And actually, this is what a lot of ancient tribes, primitive tribes, did. And I think some of them may still do this. So pairing is actually a little bit more fundamental than counting. I'll get more into that later, but I just thought I'd mention that. That's another way you can determine whether two sets have the same size. It turns out you can use the same method for infinite sets as well as finite sets. That's why I thought I'd mention it. I'm kind of giving you a little bit of a preview here. Cardinal number is not quite as basic a concept as you might think. And counting isn't really as basic an operation as you might think either. So anyway, I just thought I'd mention that. So I'm gonna just give you two simple examples here, and the reason with these examples, I guess I'm kind of bringing home the point that you don't have to count the number of elements in a set to determine whether two sets have the same cardinal number, also known as the same cardinality. And so for the first example, let's consider the set of even numbers and the set of odd numbers up to 10. Well, I think that's very easy. The odd numbers are just 1, 3, 5, 7, 9, and the even numbers are 2, 4, 6, 8, 10. Very easy to count them. You can see right at a glance there's 5 elements of each set. But suppose you were really stupid. Suppose you didn't know how to count to 5. Suppose this is before kindergarten. I guess you haven't learned how to count yet. Is there another way you can determine that these two sets have the same size? Imagine you're a little toddler playing with numbers, and you have the numbers 1 through 10 in front of you, and you have them separated. Yeah, maybe you didn't do this yourself, but maybe your dad separated the odd numbers and the even numbers. Another way you can determine that there's the same number of odd numbers as even numbers? Well, yeah, just pair them up. Pair 1 with 2, 3 with 4, 5 with 6, 7 with 8, 9 with 10. That's a pairing off, and there's no numbers left in either set left over. If you had another even number, say 12, then you could see at a glance there's more even numbers than odd numbers. In this case, there would be 6 even numbers and just 5 odd numbers. But you wouldn't even have to know that. You just know that they pair up. So it's the pairing that tells you that two sets have the same cardinal number, same cardinality, in other words. Let's do a little more complicated example. Suppose our first set is a set of seasons of the year. Winter, spring, summer, and fall. Some people like to start with spring. I learned to start with winter. I guess it depends on what convention you like. I don't know. I mean, James Taylor started with winter. He sang winter, spring, summer, and fall. All you gotta do is call, and I'll be there. Yes, I will. You got a friend. Anyway, enough of that. But, anyway. So we all know there's four seasons: winter, spring, summer, and fall. And say our second set is the set of months January, April, July, October. And again, this is an example where you can see at a glance there's four elements of each set. But suppose you didn't know there were four seasons or that there were four of these months. How else could you do this pairing? Well, pair January with winter, April with spring, July with summer, and October with fall. And this is kind of a unique pairing because these are the first full months of each season, at least in the northern hemisphere. So that's another way you can determine that these sets have the same cardinal number. Of course, these are very basic sets, very small cardinal number, but you can do this for bigger sets. I mean, maybe you have a set with a few hundred elements. Maybe you have crystallographic point groups or something. There's a total of 230 of those in three dimensions. Maybe you have a pairing where you have certain types of, I don't know, crystals that have each of these 230 crystallographic point groups associated with them. Maybe you don't want to count it 230, but maybe you have a complete list, and you also have a 230. You don't have to count them all, but all these particular crystals with each crystallographic group. I'm just trying to give you a little more interesting example. So, this might even be practical for certain examples. Anyway, so that's how you determine that two sets have the same cardinal number. And anyway, that completes my video for today on finite cardinal numbers of finite sets. So thank you for watching, along with math, and I'll see you guys next time. Bye.